Hello and welcome to NextFest. My name is Dr. Nick Brown and I'm a lecturer in the School of Engineering here at RMIT University. Today I'm going to tell you a little bit more about the engineering degree programs that we offer here at RMIT. These programs are world renowned and allow students to work across a variety of disciplines to replicate the real world experience that they will need once they start their careers. Now during this presentation I'm joined by a whole bunch of my lovely colleagues who are here as moderators, and they're going to be in the back end answering all the questions that you have. So that's going to be via the chat function. So you won't be able to ask the questions directly to me, but rather just that you see the chat box there and the question and answer box there in front of you. Type the questions that you have, and one of my lovely colleagues will get back to you during the presentation. And some of those I'll try and answer at the end as well. Before you do ask your question, just have a quick read, see if anyone else has already asked that question so you can get the answer straight away. But also, if there's one that pops out at you that you're really interested in or you want a little bit more information on, then please feel free to give it a thumbs up and we'll come back at the end and tackle some of those questions at the end of the presentation. Slide, please. Now, Aboriginal Australians are the world's first engineers, with examples of engineering creative problem solving in Victoria, really close to where we are today and where I am today in Melbourne. For example, the Budgebim cultural landscape located on the traditional lands of the Gunditjmara people was recently recognised with a World Heritage listing by UNESCO. It's a system of waterways and channels that are designed for sustainable aquaculture and has been maintained for over 6,000 years. As engineers at RMIT, if we respond to the offers of knowledge from the Gunditjmara people, then we might ask ourselves, how might we build the next generation of infrastructure, products, services with, say, a 6,000 year life cycle? And it's a really interesting way of thinking. Responding to those offers of knowledge starts with knowing whose country you're on and acknowledging the traditional custodians of that country. And so I'd like to start today by acknowledging the people of the Willrmit and Boonwurrung language groups of the Eastern Kulin Nation, whose on unceded lands we conduct the business of the university. RMIT University respectfully acknowledges their ancestors and elders, past, present, and also we acknowledge the traditional custodians and the ancestors across the land and waters where we conduct our business. Next slide, please. RMIT is committed to redefining its relationship and working with and supporting Aboriginal and Torres Strait Islander self-determination. The university's goals is to achieve lasting transformation by maturing its values, culture, policy and structures in a way that embeds reconciliation into everything that we do. In line with the principles of Bunjil, we are changing the ways of knowing, working and being to support sustainable reconciliation and an active relationship between Indigenous and non-Indigenous staff, students and community. Next slide, please. So what do engineers do? What is engineering all about? Well, engineering is primarily about problem solving, and it's about making the world a better place. It's about using creativity, problem solving, ingenuity to devise new solutions to existing problems or look at an existing problem in a new way. And this affects every single part of life around us. If you had your morning coffee like I did, then how did we get the water to that coffee shop in a pure sense and in a good quality water? How do we get the power there to be able to power that coffee grinder and the coffee machines and all the other kind of services that go on around us? It's the buildings that we live in, the devices that we use. Increasingly now we're living in a high-tech world, and engineers are at the core of every single part of that work. So next slide, please. Now this video of RMIT students, how engineers are professional problem solvers.
An engineer is someone who sees an opportunity where others only see a problem.
You might fail the first few times, but to get ahead, you really need to challenge yourself.
The more you practice solving things, the quicker you get at figuring out how everything works.
Like designing steel structures to support a high-rise building.
Or teaching a robot to see, as well as navigate the space and move an object.
Or building a drone. that can lift a heavy payload or survey the land.
Engineering's pretty much professional problem solving.
I learned about electronics by trying to make the fastest racing drone I could. Now I get to test my design in the industrial wind tunnel. That's what I really love about RMIT. It's hands-on learning with a purpose.
Thanks to my experience at RMIT, I got an internship, which became a part-time job that I'm really passionate about. As a junior engineer at Crusader Caravans, my focus is on making the manufacturing process more efficient. I even got to design a new layout for the entire production facility.
I'm always amazed at how modern buildings can reach the sky. At Multiplex, I work with contractors on inspecting structural features. I love that we use innovation to make sure the building is safe, exceeding the highest standards.
Where others might see barriers and obstacles, engineers see an opportunity.
We already have all this amazing technology. RMIT challenges you to find new and innovative ways to use it.
So giving you a bit of a sneak peek into what engineers do and what our engineers do and what our students do after they graduate from RMIT. So we've just explained there that engineering is all about understanding the real world problems that exist and then designing solutions to solve those problems. It is about creating new products and new systems, but it's also about taking a step back and thinking about how we research new innovations. A lot of the work that we do at the university is in that research and development space as well. And me and my colleagues take all of the work that we're doing in the research labs, coming up with new products, new innovations, new ways of thinking, and we bring that into the classroom and make sure that comes through in our teaching as well. So all of our students learn from that experience. It's about, but it's also about thinking about products and services long after they have been created and innovated. It's about thinking about how we maintain them over the course of their entire lifespan. And in fact, increasingly now thinking about what happens later when we're thinking about decommissioning products and systems as well. Next slide. So hopefully now you've been pretty inspired to think, yeah, this sounds good. I want to be an engineer, but what can I study? Well, here we go. Next slide. There are really two options for you. If you already know which kind of specialized degree that you might be interested in, and that is because there are lots of different types of engineering, which we'll talk about in a little bit of a second. So if you already know sort of what type, what field, what discipline, you might hear these different terms used, then you can go straight into, you potentially should go straight into a specialized degree program. If you're not that sure, you know you want to be an engineer, but you don't know whether you want to be a civil, a chemical, or electrical engineer, then at RMIT we have this fantastic program actually called the Bachelor of Engineering Honours Program, which is essentially, you can think of it as a bit of a flexible first year. It's a way to dip your toe into the water. And in fact, the program manager for that program is on the Q&A as well. So if you've got any questions specifically about the Bachelor of Engineering program, do please ask those in the Q&A. Next slide, please. So that's engineering, and we have these different options. So the Bachelor of Engineering, as I was mentioning, is one where you're basically gaining those sort of fundamental engineering skills that are core and common, like across all engineering disciplines. All engineering disciplines have to think about problem solving, have to think about defining problems. It's also a lot of engineers need to have a certain level of mathematics. You have to have that mathematical thinking. And so the great thing about the Bachelor of Engineering program is that any level of maths you can get into the program, and any boost that you need you'll take one or more of the maths programs or maths courses that we have to make sure that your maths is at the level that's appropriate for the discipline of engineering that you want to move into. It's also a great way to start to explore different forms of engineering. So especially in the second semester, you'll get to choose from a range of different courses. We call these sort of electives. You get to pick one. And you can elect to take these courses and learn maybe a bit about chemical, a bit about civil, a bit about electrical, whatever it might be. And then you can make your decision at the end of that first year and move into one of those specialised degree programs. And that doesn't put you back at all. That's just, you then just move straight into second year along with all the other people that chose the specialist degree program. But if you want, you can choose a specialised degree program. Next slide, please. And so this is for if you know that you want to be an engineer and you know exactly what you want to do, then I'd recommend probably picking a specialised degree program. So for example, for me, I knew that I wanted to be a civil engineer. And so when I went to university, I chose a specialised engineering program in civil engineering. Well, fortunately, RMIT actually offers 11 different single engineering degree programs, and these range from things like advanced manufacturing mechatronics through to sustainable systems. Those are electrical, electronics, mechanical, environmental, chemical, civil, and biomedical as well. So there's so many different types of engineering that you can get involved with, and we have a degree program that's going to work for you. Next slide, please. Now, if you think just one degree, that's no good, I want a second one too, please. Then actually we have 16 different programs which you can choose from, which are called double degree programs. Now, a standard engineering degree will take 4 years for you to complete. However, if you're happy to stick around for an extra year, then across 5 years you can complete 2 degrees, 2 bachelor's degrees. So that's not like civil engineering and business management. That's 1 degree in civil engineering and 1 degree in business management that you're completing in parallel. Now, if you remember earlier, I mentioned that word electives, and the thing about you doing a double program is that you don't get as many electives because you're choosing courses from the other program. But don't worry about that, it's getting into too much of the details. The point is that doing a double degree is a great way to extend your knowledge and to study something which really complements your core engineering course. So for example, you probably are aware now of how much business plays a role in modern engineering practice. Think about some of the most famous engineers that you know. The chances are they've probably got a good bit of business acumen behind them as well, to allow them to combine that technical knowledge with actually getting a product into the real world at a price point that actually is going to work for people. There's also some great science projects as well, science programs that, obviously engineers, it's all about taking the science and actually applying it into the real world. But if you want to gain some of that more theoretical understanding as well, understand where that science that we apply comes from, then obviously doing a double degree with science can be really beneficial too. But there are lots of options for you. Next slide, please. So hopefully now you understand what an engineer is and you understand what kinds of engineering you can do at RMIT. But next we should talk about why you should study at RMIT. Next slide, please. Well, one of the reasons is that we have some really interesting and cool additional opportunities beyond that take you outside of that specialization. So my field is actually called Humanitarian Engineering, and this is where we're specifically looking at the application of engineering technical skills into more marginalized communities. So we specifically look at how you can take your mechanical engineering skills, chemical, civil skills, and apply them, say, in a post-disaster response situation or in long-term development. So obviously you will have seen right now, right around the world, and unfortunately at the moment, there's obviously a bit of a refugee crisis that's coming out of Afghanistan. So it will be up to engineers to actually make sure that when those people arrive in a place of safety, that they are provided with the shelter, the food, the water, sanitation services, power, lighting that they need to to be okay and to then move on to another port of safety. So engineers have a really important role in this, and actually it's one of my favorite things is that we through the humanitarian engineering programs, you actually work on real world problems from day one, actually, in a course that I teach. So we actually work on a real humanitarian challenge for your first project, and then as we move through the degree program as well. There's opportunities to come and travel and work in communities in like Timor, Cambodia. We're working on projects in Solomon Islands, a great project in Fiji. In fact, the photo that you can see on the slide here is of some students in Fiji measuring a rainwater tank to understand capacity and how we can best manage the water flow within this water tank to make sure that the community have access to water all year round, not just in the rainy season, but also through the dry season too. So really cool programs to get involved with. Next slide, please. And project-based learning is really important as well. And that's something that we really are very passionate about at RMIT. We have great links in so that, as I was just mentioning there, in the courses, you're not just working on theoretical stuff, you're actually working on real projects with real partners or on real piece of kit, real things. After all, like learning should be really authentic. There's no point learning something that you're never going to do in real life, right? It should really match that. And so you should work on real engineering projects. There are some amazing facilities that we have at RMIT, like world-leading facilities, including the Advanced Manufacturing Precinct. And again, there's some people on the chat who have got huge experience with the Advanced Manufacturing Precinct. Advanced manufacturing, you might also have heard the term additive manufacturing, or more colloquially known as like 3D printing, and RMIT has some of the coolest kit around, and students get to get hands-on with that kit. I'm talking about like 3D printing, like in aluminium and all kinds of metals and all kinds of interesting polymers and advanced materials. It's incredible. There's obviously also great ways to get involved in real-world projects, for example, through the Formula SAE. So that is where an annual competition where students will build a sort of Formula 1 style car and race it. There's also some really cool opportunities through things like the Solar Car Challenge and all kinds of stuff where you get to work again on these real world problems and real world projects, which is so vital to make sure that you can then actually have the skills that you need when you go into real life. Next slide, please. If you don't just want to study at RMIT, then we have some fantastic partnerships all around the world. Where you can actually spend time. So if you obviously are interested in maybe doing a semester in Europe or North America, South America, or anywhere, then there is opportunities to go and spend time at over 200 universities around the world. Obviously, at the moment, international travel is a little bit limited, but it should in the future be picking up again. And when it does so, there'll be these great opportunities to go and study. It's a great way to learn about how engineering is taught and conducted around the world, and bring that back to Australia and think about how that applies to your own practice. It's obviously a great way as well to understand different cultures and to really understand engineering around the world, because engineering is a massive global it is a massive global thing and a massive global business. Engineering companies are multinational, and so having that understanding of different cultures and engineering in different countries is really vital and can give you that cutting a little bit of edge when you go into the job interview in the job market. Next slide, please. And of course, there's not just the work experience directly overseas, but we also have really interesting opportunities for doing study tours as well. So these are more short-term placements where you, as a student, you'll actually get to go and spend some time in, say, a couple of weeks, 4 weeks, 6 weeks in another culture, learning about that culture. And again, as I said, being able to take back as much stuff as you can when you come back to Australia. And again, you'd be surprised by having that additional edge, how important that is when you're trying to set yourself apart from the other people that are going for those engineering jobs. Next slide, please. Now, of course, the vast majority of our students want to go and work in the engineering industry. Of course, engineers are highly prized in other industries as well, and so some students do move into other spaces as well. But wherever it is, we go into what we sort of tend to call the professional services industry. So that is where we are using our knowledge to answer a particular question or a particular problem that is put to us. And that means that because of that, we want to make sure that the industry element is incorporated into as much of our experience and much of your student experience at RMIT. This means that there's a much more gradual transition. You don't want to really be graduating and finishing university and then having never experienced or never stepped foot in an engineering office before, right? You want that transition to be as gradual as possible so that it seems real seamless. We love it, of course, when our students manage to get graduate positions with industry organisations that they've already maybe interned out or spent a summer with, and they've already got a job offer before they've even finished university. I know that Matt, who's on the chat today, who runs our environmental engineering program, he's very particularly proud of the fact that the vast majority of our environmental engineers have already got a job offer before they even graduated. But this is done in a number of ways. So of course, work placements, great way to get that real world experience. I'd highly recommend you to be looking for real world experience to complement your studies as early as possible. Again, going back to that problem-based learning, we work with industry partners. So we've got a number of industry partners that I'll be talking a bit about later. We get them to bring projects and their problems that they're struggling with in the real world, give them to students, give them to you. You've got these fresh eyes to look at it, and you come up with some of the most amazing solutions that that industry partner wouldn't have been able to come up with on their own. But it gives you a great opportunity to work on these real world projects as well. Of course, there's more sort of traditional ways of having seminars, having people from industry come in and talk to us and talk to you as students about what life is like, what the problems that they're working on, see again that gradual way, and it's a great way to network with those industry partners. And one of the coolest things that we do is, again, all of our final year students work on a real world project. The vast majority of those come from industry or have some kind of industry sponsor or industry linkage. And at the end of the year, we have this really cool exhibition called Ingenious, where all of our final year students get to showcase the work that they've done with industry. And it's a real, as I said, just basically a big showcase where we get to see some of the coolest things. Now, the next slide is going to show a video where some of we're going to hear from some students who are talking about how they've made a difference through projects that they've been working on with industry partners.
I think engineering is about helping people in the real world. Our goal is to help children with limited mobility use technology in a new and exciting way.
We're a team of engineering students at RMIT, and we're working on a project to help children paralysed from the neck down by creating new technology. The aim is to create a connection between facial recognition and robotic arms. But first, we have to capture and learn all possible expressions.
The challenge is translating all these facial movements into computer code. This way, we can communicate directly with the robotic arm.
I always loved tinkering and just making things. But this project is different. It's not just for an assignment. It's for a real client, for the real world. This could be life-changing technology.
Building something completely new is about balancing imagination and practicality.
As we said last time, I forgot this is layer by layer simulation of the 3D printing.
We're fortunate that at RMIT University we have amazing facilities and great guidance to make our project a reality.
As we continue to develop our project, it's important to share our progress each step of the way. Engineering is about building something new. It's so rewarding to see how this technology can bring new possibilities into people's lives.
So hopefully you've seen there a little about how all of our students work on real world projects that are going to better society and improve the life of everyone in Australia and overseas as well. Now, something that's really important is that all of RMIT's degrees are accredited by Engineers Australia. Now, Engineers Australia is the peak body for engineering in Australia, kind of what the name suggests. And what that means is that all of our degree programs have been accredited, means that we've had industry experts, experts from engineering come in, evaluate the programs that we're running, really interrogate them, talk to the students, talk to the academics, talk to all the support team, and make sure that the quality of the education that we're providing is absolutely first class and is top rate. And again, I'm glad to say that all of our programs have been accredited, and that means that that once you graduate, you can be recognised as an engineer in Australia and get that graduate membership to Engineers Australia, and then that's really vital as well because it's an accredited degree. That means you can also be recognised as an engineer, not just in Australia, but actually in many countries around the world. There's about 15 countries. There's Washington Accord. Don't need to go into the details. The point is that, for example, you may have noticed from my accent that I'm actually originally from the UK. Well, my degree that I got in the UK, I studied engineering in the UK, is recognised again by Australia. So that means that when I moved to Australia, my qualification was recognised and I could start practicing as an engineer in Australia. Now, if you study at RMIT, you would be able to do the reverse. Go to the UK, for example, rock up and just say, yep, I'm an engineer. I've been recognised by Engineers Australia, and therefore I'm recognised as an engineer in the UK. You can start practicing in the UK as an engineer. Don't need to do any further qualification or any kind of like further exams or anything like that. So it's a great way to make you globally mobile. Next slide. And I mentioned earlier that we have some fantastic industry partners who support the work that we do. Here's just a single slide of some of those that we work with. You can see a range of engineering industries, very large partners, very large multinational companies, some slightly sort of more medium-sized companies as well, which is great because different industry partners are offering a different amount. And again, it's so vital that they pull in and that they're a part of the teaching as well, because it means that everything that our students do are in that sort of more practical side. And next slide. So hopefully now I've told you what engineering is, the different types of engineering, maybe why you should get involved at RMIT University and some of the additional things that come around the degree. Now it's probably time to get into some of the more practical information. Next slide. So just remember that there are obviously prerequisites to study engineering at RMIT University. We have the VTAC guide and the RMIT website have all the details that you're going to need for in terms of things like the ATAR scores that you're looking for. Just remember that there are some slightly different entry requirements for two of the programs. So biomedical engineering at the top there. You need units 3 and 4 with a study score of at least 30 in English and at least 25 in English other than EAL, and units 3 and 4 with a study score of at least 20 in any mathematics. Sort of similar story with Bachelor of Engineering, Chemical Engineering, but you do need at least a study score of at least 20 in chemistry. So there's that additional factor that you need, that chemical background. But then again, in our Bachelor of Engineering program or all of our specialist degrees, so basically everything else, you really just need to have that bit of that maths background. So units 3 and 4, a study of at least 20 in either maths, mathematical models, or maths and specialist maths. So it's that mathematics that we're looking for as a bit of a sort of a prerequisite. That sort of, you really want to have a bit of that mathematics. Again, as I said, you'll learn more of the maths that you need whilst you're at university, but it's really important that you come in with that bit of an understanding in the background. Next slide, please. So there are a couple of different pathways as well. So something that's really cool about RMIT is that we also have the TAFE component, and there's also different ways that you can come through. So for example, please do check out the website. It's got all this information in a lot more detail. I don't have enough time really to go into it. Pathways.rmit.edu.au, but essentially you can come in for 4 years by coming through an associate degree in engineering technology, and then going into that one of those specialisms that you want to pick for the following 2 years. So that creates a 4-year program. Or if you, instead of doing the associate degree, you can come in through an advanced diploma in engineering, and that just requires a little bit more time in one of those specialist Bachelor of Engineering programs, so about 4.5 years in total. But 2 alternative pathways, which can be a really great way if that's something that you're more interested or is more applicable to your own learning journey. Next slide, please. And something that's really interesting is that there is also an opportunity to continue your studies. So after you finished your honours project and your bachelor's degree, you can stay on and do a master's project and a master's degree. So in fact, something that I've done, so I did a 5-year degree as a master's degree. And at RMIT, we offer this 4+1 model. So normally a master's degree would be a 2-year program. So if you thought about it, it would be 4 years of bachelor's and then a 2-year master's. But if you do it at RMIT, we recognise the fact that you've already come through our undergraduate program, and so you can add on a master's degree in just 1 year. So this means that you do your standard Bachelor of Engineering degree in any of the specialisations that you like, and then you do an additional 1 year in a Master's of Engineering. Now, what's really cool about masters is that it allows you to either specialize in something. So for example, some of our master's program allow you to look at one very particular area, one very specific area that you might be interested in. It might also be a way to transfer a bit of your knowledge as well. So if you've studied one branch of engineering, you might choose to do a master's in something that's affiliated, that's close by, so that you're getting that sort of double up of engineering knowledge. So it's another really great way of learning and of extending your study at RMIT. Next slide. So thank you so much for listening to what I've had to say. I can see that there have been so many great questions that are coming in via the chat box. You might see me just looking off to my left here, just because this is where my chat box is, and I can see that there are so many questions that have come in, so thank you so much. That's absolutely awesome. There are some questions that please keep posting those questions. I'm going to sort of answer some of them that have come in. So there's a great question here about what is the day-to-day life of an engineer actually like? What do you do at work? It's a great question, and the fantastic thing about being an engineer is that it can really change from profession and whatever you're working on. So when I was working in industry, yeah, there would be a lot of time spent in the office because you want to be sitting there devising, doing design, working on your models, those kinds of things. But you also then spend time out in the field. So engineers often involved in site visits, maybe visiting a manufacturer, or for me, I was really interested in water and I worked for a water engineering company. So we would go out and actually, do water testing, go and visit waterways around the area and sort of test those waterways. But yeah, it depends. Also, as I mentioned, some engineers get involved in that very hands-on sort of practical work. You might be on site supervising technicians actually applying something, or you could be in a lab, as you said, actually developing the latest technology. So that's something that's really exciting as well. Someone's asked how much practical versus theory there are in engineering degrees, and I'd say it's a real nice blend that you want to try and get pulled together. So of course you need to have that theory of understanding. You need to have that knowledge, that base of knowledge that you want to pull together, but also you need to have that sort of practical application, and it's the balance of both. Industry and employers will be looking for that. They want to know that you've got the smarts, they want to see that you actually know your stuff, but they actually want to see that you've actually done it. So you want to have that bit of practical experience, and that's again what we try and bring into the course as much as possible and into the programs as much as possible. Someone's asked me as well, like, how did I enjoy civil engineering and why did I choose it? It's kind of a bit of a bizarre question, really. I was actually in love with geography. I absolutely loved geography, and initially I wanted to study geography at university. Then I actually went to. I know this is gonna sound like it was like scripted, but I promise this has just come in and it's not. I went to a university open day, and I went with my mate who wanted to study electrical engineering. And next to the table about electrical engineering was a table about environmental engineering. And I looked at environmental engineering and I said, hang on, this is just like flood management, urban design, transport infrastructure. These are all the things I'm really interested about from geography, but it's actually more practical and actually more real world. And that's when I actually had that sort of almost light bulb moment where I was like, oh, actually, I think I want to be an environmental engineer. And then when I went to university, I selected a program that was environmental and civil engineering so that I sort of had a bit of a balance between the two. So that's how I chose to do environmental engineering. And then throughout my time at university, I became more interested in this idea that actually in engineering, we have this amazing ability to improve the world around us for everyone, make it more accessible. And I got really interested in this thing called accessible design. So making the world more navigable for everyone. And that led me through to the humanitarian space, which I'm working in today. Someone's asked a really great question, which is, will RMIT help get internships, or will you have to fund them for yourselves? We will definitely help you find internships. As I said, in some instances, those industry partners come to us and say like, hey, we're looking for, a few students to join. Have you got anyone that you think would be suited for these kinds of roles? And that's great. That's what we want, so that we can almost, put you into those positions pretty quickly. But no, normally you also will have to do a little bit of that legwork yourself. Not a bad idea. For example, as a student, you get student membership, free membership to Engineers Australia as a student. That's a great way to go and network, meet people, see what people are up to, go and shake hands and actually, COVID safe, of course, and go and meet people and see what opportunities and offers there are out there. So I'd say the university does have a lot of support mechanisms to help you get those internships, but you have to you should really be thinking about putting in a bit of the legwork yourself as well. A bit of a get up and go attitude will really help you because after you graduate, like RMIT won't be there at that stage. So in 5 years, 10 years after you graduate. So you want to be getting into that idea of going out and looking for opportunities yourselves. So someone's asked, like, what would you say the points of difference with other unis are? I definitely get my colleagues on the chat to chuck in their thoughts as well. I can only really provide my ideas, but I'd say that real world realism, that the fact that for example, I teach a course called Introduction to Engineering. It's literally the first course that you do at RMIT, first year, first semester, week 1, day 1, and you're working on a real project with a real industry partner, not like they're just giving you something to work on and then you just work on that. You actually then pitch back that idea, that design that you come up with, back to that industry partner. And that just happens throughout the degree programs. So there's it's that real practical application. And so RMIT graduates are known, RMIT engineering graduates are known for having a lot of that sort of work experience and that practical ability. So answering that previous question, it's that real nice balance between the theory and the practicality of engineering that we teach here. Someone's asked, how would I describe the ratio of men and women in general in the field of engineering? Yeah, look, definitely there are fewer women in engineering than we'd like to see. And RMIT has some great programs and some great initiatives that are there to try and see if we can change the balance and get more women into engineering. But also, it's not just about attracting women into engineering, it's about creating really interesting spaces and making sure that the people that join us want to stay and can engage with the profession. So we also do a lot of work to make our spaces real nice places to learn, make sure that they're included, so that basically anyone who comes through our doors feels a sense of belonging, feels like they're included as an engineer, feels like they belong as an engineer, and want to study and want to move into the engineering profession. In fact, I'm sort of involved in a couple of projects related to that, where we're looking at improving the sort of belonging and making sure that everyone feels like they belong in engineering. So someone's asked, what's the difference between a science degree and an engineering degree? So much, but I guess so little. The point is that, like, you can think of engineering, often gets talked about, you might have heard this saying, like, as an applied science. So, you know, engineering sort of is science adjacent, but we're really where the rubber hits the road. So whilst scientists might think about something that's more theoretical in nature, engineers, it's all about actually applying it in the real world. So not just thinking about how water moves in a pipe, but actually taking that theoretical knowledge and saying, right, well, let's use that theoretical knowledge to actually design the water infrastructure that exists in our cities. How do we actually use the science that exists to make the best world possible and make a sustainable world? What's the difference in job prospects? I don't know precisely, because I'm not a big scientist, but you know, certainly you should look at some of the salaries for engineers. They're pretty competitive. So you know, it's a good field to get into. Of course, there's more to life than money, but you know, certainly it helps. And so yeah, so that's a really you know, that's sort of one of the differences, but it's sort of that more practical based, if you like. Yeah, let me see. I'll try and get some more questions. Someone said, how competitive is the engineering field? Look, the engineering is a really interesting sector. Of course, like a lot of sectors, it changes depending on government spending. You know, at the moment in Victoria especially, there's a lot of money, you'll notice, going into infrastructure. So, you know, we're just building the new metro tunnels. In fact, the metro tunnels were going under RMIT University. They're digging the tunnel that's heading north, and actually quite a lot of RMIT engineers students have been involved in that as interns, or been involved in the metro project for a while. There's also a lot of projects, a lot of infrastructure going on, like the new railways, the new rail lines, the new circular rail lines, and those kinds of things. So yeah, at the moment, you know, it's definitely a good opportunity. And by the way, don't just think about railways as like being like things for civil engineers. Of course not. You know, there's going to be new trains, there's going to be new vehicles, that's mechanical, automotive. You need new signaling systems, that's communications. You need new power supply systems to provide those, you know, so that's electrical, electronic. Like, engineering is involved in all these kinds of things. I'm just trying to read through the questions again. Someone's asked, I don't know if this has been answered. I'm not too certain of the percentage of graduates who find work within the first year after graduating, but I'm sure someone will be able to answer that. I'll get you some information on that. No worries. Yeah, if there are, keep the questions coming, and I'm just trying to read some of these more off, but I think we're sort of getting to the end of those questions. Let me just have a quick look. Sorry, I'm just trying to read it now at the same time. I think that's pretty much, that's all the questions. All I'd say is that you know, hopefully you've learned a lot here, and we've answered some of the questions that you've had. Please do reach out to the team. Obviously, there's contact information for the school if you've got more questions that you know. I know these things. You may be watching this or attending this, and then after the fact you think, oh man, I wish I'd asked that questions. Well, don't worry. There's methods through the open day system to ask those questions, and someone will get back in touch with you. But anyway, look, thank you so much today for taking the time to learn about our globally recognised programs. And again, for more information on these programs, please be sure to check the program information available through the websites. That's all from me today. I wish you the absolute best, and hopefully, as I said, I teach that first semester, first year course. Hopefully I'll see some of you next year and get to meet you in person and face to face, and I'm very much looking forward to that. Okay, thank you so much. Have a good day.